Okay, question number 3. I can use the calculator and see what that gives me because I'm looking for the limit as x approaches negative infinity of 2 to the power of x plus 5 to the power of x plus 5, and get rid of that plus 5 over there. And that tells me it equals 5. And 5 is the answer because 2 to the x approaches 0 when x approaches negative infinity, because 2 to the negative infinity is going to get a number so small it's going to go to 0. So 0 plus 5, 5 is the answer. So if I'm going to now take the derivative of this, calculate derivative, okay, that gives me g dash of x equals 2 to the x log base e of 2, therefore k equals log base e of 2. The AB real number, find in terms of the equation of the tangent to that point. So if I take this and I wish to calculate a tan line at x equals a, I get that expression. Okay, so this is the bit that's got an x in it. So I can write y equals 2 to the a log base e of 2 plus 2 to the a plus 5 minus 2 to the a log base e of 2. Make sure you write it exactly as it is. Hence or otherwise, find the equation of the tangent that passes through the origin. Okay, tangents that pass through the origin. Bound book, go to the case of tangents that pass through the origin, and f of x f dash of x equals f of x on x. So f dash of x is where I take my derivative, that's my derivative there, equals fraction f of x on x, and solve for x. So the tangent is at that particular point. So I can say I'm going to do my tan line again, but I'm going to place it at this point. That number is so small, it's 0, because of course it goes through the tangent. So I'm looking at y equals 4.2547, so 5x. So just to get my full marks, 2.617847, and there is my tangent line at that particular point. So now we have 2 to the x minus x squared still. Find the coordinates of the point of inflection. So the point of inflection, I've got two ways, it's to two decimal places. One way is to graph it, because it's two decimal places, edit, clear all, okay. And I'll put this down here. Oh, it's up there. And I might want to make the y value go up a bit higher. Oh, I've got the graph wrong, got it wrong. My apologies. So I've got 2 to the x minus x squared. And drag and drop up. And I'm looking for the point of inflection, G solve inflection. And there it is there. 2 decimal places. So we're looking at 2.0576 and negative 0.07. The other way to find it is you take the second derivative. So calculation diff, I'm looking for the second derivative. And that tells me that in standard, and when that equals 0, that's where your 0.26 comes from, and then you can sub that back into here to find the y coordinate. And I get negative 0.07. So there's 2 ways of getting that. Find the largest x interval for which h is strictly increasing. Okay, so from this graph, I know where my point of inflection is, and it's going to be strictly decreasing. I also need to know the coordinates of the turning point. So if I go analysis, G solve max, that tells me that it is 0.4, 2 decimal places, 9, and analysis G solve min, and that is 3.21. So 3.21, and it's strictly decreasing, strictly, so square brackets.